All right, and welcome to the giant drill part of the bow drill. So we're going to be looking at a few ridiculously sized devices here, and not very practical, but a lot of fun, I have to admit. They're real projects to make and do, but well worth it when you pull them off with a real sense of satisfaction. Now, what I want to say is still, we're trying to do everything as one person. So a lot of times that I've seen the giant drill done, the giant bow drill anyway, it's always done with a whole bunch of people. Somebody's got to hold it up and support it. You got like 4 guys trying to work the bow back and forth, and but we're trying to do everything again as if it's just you and you by yourself, and you need to figure out how to balance all of those variables, all 22 variables that you are probably now well versed with. And as you can see, I'm not going over it so much now because it should be almost instinctual for you to try to, if you're practicing, to try to balance them all out if you don't have them memorized already. So I'm going to be introducing a new device called the pressure lever brace. And what it is it's attached to a structure, and that holds the spindle in place. Okay, so you're not holding the spindle. What's great about this device is it pretty much removes from yourself having to deal with it, pressure, because you're going to be stacking weights on top of the pressure lever brace, and stability, because the pressure lever brace holds everything in place while you bow, because this thing is so huge. There's no way you can expect to hold this set together and bow at the same time. I mean, probably the limits of that was the crutch drill. So when you get into the giant drill, you need other structures and some very large structures to be able to pull this off. All right. This section also will not get very involved with this. I'm going to tell you right now, what's necessary is that you thoroughly go through the toggle drill section. Okay. Now the toggle drill section, we're going to get really into creating and balancing the pressure lever brace. So if you're before you do the giant drill, and I'm going to say this, don't do the giant drill until you've done the toggle drill. Okay. So the next section after this is the pump drill, and after the pump drill will be the toggle drill. And after you've thoroughly gone through and over the toggle drill, I recommend you go back and do the giant drill if that's your wish. Okay, but I don't recommend you do it before. Just out of you'll understand more things with having done the technique and the method of the toggle drill first. All right. What else we got? A reload is expected, by the way, in the giant drill. Okay, for example. Now the pieces that I have here are all cedar. Okay, these were all made out of cedar fence posts. Now the spindle, again, because if you want to do a reload, can be any wood. Now, you're probably, if I could find one here, you're going to grab some kind of sapling. Okay, this is a section of apple, a rather large apple branch, which came down in that snowstorm in my neighbor's yard. And with this one branch here, I'm going to be turning this one later into a spindle for a, if not a giant drill, then definitely a very large crutch drill, which will be a torque drill. All right, that back. So these devices that I have here, now you saw this probably way earlier, and this is the example that my friend Dan Stanchield made for teaching the bow drill, because he taught the bow drill at the school. Okay. Now, as you can see, the top portion is a tall point, like a pencil point. He has it marked here to show that this is actually the brace end, and you can see how tall it is. And the bottom base end here, as you can see, is a shallow point. Now, this is a model for people for creating a bow drill spindle, okay? But obviously, if you took this and you made a giant drill device out of it, it would probably work. And you can see it's very centered on its axis as I spin it. Dan did a lot of good quality work when he worked at the school. This is another cedar fence post. As you can see, it's riddled with knots from the branches of when this was a tree. This has a plug in it of sodal, and this sodal plug is in actuality 2 3/4 inches, 2.5. We'll say just over 2.5 inches in diameter. Okay, that's really large, right? So now this could just about almost be a torque spindle, because obviously the spindle is a little larger than the reload, but when you get more toward the center, it does taper. So when you get more toward the top, it is thinner. So I would say that the top brace end is in itself 2.5 inches over here, but the actual brace end, not the reload, but the brace end is 3.5 inches across. Okay. But what really counts is where it spins in the middle, where the cord is that does the turning. Okay. So I'm not quick to call this a torque spindle. I would really just call it a reload spindle. Actually, this one. Just as a comparison as to how tall this is, if I put it on the floor, I'm 5'6". Okay. So this is probably 4.5 inches tall, right? I mean 4.5 feet tall. This is the base that Dan Stanchield made for teaching to go with his giant bow drill spindle as a demo of how to create one. And you can see here he has how you get the measurements on the base, and for mating, how that would go in. That's actually darkened in with a black marker that he did. And then his cutting of the notch on this one as an example, and getting the correct angle, that piece of pie. Okay. Now the setup you would make would be kind of similar to this, but you need to balance everything out. All right. Otherwise, you can end up with things like this. So you start drilling, but this whole thing cracks out because it got really thin, and the grain. There was probably a crack in the grain like this. Now this is going to be definitely going to be a torque spindle. You can see it's short because it's going to be up on the table. But these fence posts, sometimes when they dry, they have these long cracks in them. Okay, so if you go to make a board out of something, you have to be careful that cracks don't destabilize whatever it is that you're making. Alright? So put that aside. Now this piece here, I'm going to introduce to you the concept of the reloading base. Okay, this time around. Now you could get smaller with it, but this will be the first introduction that I have of it. So what we do is we take a section of base and place it inside a stable structure, and this is all you would need instead of having to create something like this, right? Obviously you're not going to be stepping on this or this. So this is the reloading base for this spindle, and in a few minutes I'm going to show you the pressure lever brace that I have made. And again, the pressure lever brace that you will see is not the ones we would start off with, not only in nature, but for the toggle drill you need to have the basics of the pressure lever brace down. And what I'm going to show you for the giant drill is not the basic. Okay, so again, this is just a demo, and I'm just doing this for the review because it's part of the bow drill section. But you definitely need to go to the toggle drill section, go through all that first, and then if you want to do the giant drill, then do it. Okay, so this Sodal reload here fits right into this reloading base. Okay, it's right in there, and we're going to get that going. Now, I'm carving out this torque spindle. I'm going to put a hole in it for the base end. Okay, this is the brace end. We're going to put a hole in it, and this will be the base end, and get this going too. So I'm going to show you two. I'm going to show you this one with the reload of Sodal, and I'm going to show you the short torque one, and then we're going to move on to pump drill. Alright, and wait till you see my bow. You're going to like that too. It's huge. Alright, let's have some fun. Let's keep going. Alright, so we're in the science of the basic form for the giant drill of the bow drill, and this is a better view of my messy Hi dojo. Hi, again, in Japanese means fire, and dojo is place of the way. So this little structure here that I have in my sunroom, I call the Hi dojo, fire dojo. So this side of my dojo, now before you were always seeing me this way. So we're going over to the side this way just for some perspective. Now on this side of my dojo, I have the giant drill set up. On the other side, I have other structures for other methods, which you'll see later. But on this side, I'm set up for demonstrations for the giant drill. Obviously, this is not done outside. In a primitive setting, this is like take the structure down, build it somewhere else, on the go for demos kind of thing. So this is meant for inside. So this isn't a very good representation of how this would be done outside. It's close, but like I said before, you need to thoroughly go over and do the toggle drill to truly understand the giant drill. Okay, so let's start with the reloading base. Now, to the frame here, I have a shelf structure that sticks out. Okay, and I built it as a reloading base. So what we have here is our reload, which we saw before. This is a half sawed off section of a cedar fence post, which is flattened on top a bit. And this is half, as you can see, because it's almost like a half moon, except it's flattened on the sides as well. And as you can see, it's already mated with a notch. And for comparison, my hand. Okay. Now, as you can see in here, it's a recessed frame, and there's coal dust in here because, let me tell you, even though this giant drill is, in perspective-wise, is to scale like a bow drill, the notch is very high. Okay, it's a very high notch, and to cut down on energy use, because you get tired really quick, and watch how this fits right in the frame, you definitely want to fill this notch with coal extender. So we have a whole bunch here, which we put in the notch, and we fill it nice and high. Okay. Sorry about the lighting. Okay. And I have these pine boards, which fill in that space so that it has nowhere to go. Okay. So let's look at the pressure lever brace. So this is on a hinge. As you can see, it's screwed in. Okay. And a front view looks like this. Now, this is underneath. So this is the brace itself, which is screwed in to the shelf structure. Okay. And up top here I have another shelf, which is screwed in. What's screwed in is a milk crate, which holds weights. Okay. So from this other side view, and here's the other screw hinge on this side. Let me go around. You can see the hex bolt hinges there. Okay. Now, here I have a bucket of weights. These are old concrete filled weights, and they go by kilos. So this one's 2 kilos, this one's 8.8 kilos, this one's 4 kilos, This one's so dusty. This one's 14.3 pounds and 6.5 kilos. Oh, the 8x8, that was actually pounds. So it's 4 kilos. And I got another one in there. Alright, so this is the pressure lever brace. And to see the ones that I would really use, you have to see the toggle drill section. Okay, so this is a modified version of the pressure lever brace. And our reloading base, and here's our spindle that you saw earlier. Let me back up. Okay, with the reload of yucca. I mean, not yucca, but sodal. And this sodal is held in with a piece of buckskin that's wedged in there. As you can see, here's a good close-up of the bottom of the sodal. And I think we said this was just a hair over 2.5 inches in diameter, the reload. Alright. There we go. So what's necessary for the giant drill is at least 2 pillar structures, which this is one, which connects to one side of the pressure lever brace. Now the design is different for the toggle drill, but you still need 2 supporting structures. And that's what these are. But these 2 pillar supporting structures obviously are connected to the hole, which is the hidojo. Okay. But you need 2 strong pillar structures, and in nature they would probably be 2 trees together. And then you would need a crossbar that comes across the 2 trees to almost make something that looks like a chin-up bar with the 2 trees. Okay? And from there you would create your pressure lever brace, which will be explained in the toggle drill section. Now I have this bar which is nailed to my structure. I call this a bow bar. And the reason for that is and here's my bow. It is a 6-foot length of rattan, raw rattan, and it's in the moderated Egyptian bow drill cord method, where the cord is 1.5 times the length of the bow, because we're going to do the moderated method, which you just saw earlier. And usually when you do the giant drill, you have 2 people to do the bowing. Okay, and so one supports one side of the bow and one person supports the other side, because sometimes these bows can be pretty heavy, and one person, usually it's hard to hold up the other side. Well, this rattan is really light, and I could probably, it would be no problem to pull it off, to bow with one person. However, with this one extra added device, which I call the bow bar, I keep the bow level from when I'm bowing, so I don't need another person to hold up the other side of the bow. Okay. Now what I'm going to do is put the camera on the stand, and I'm going to demonstrate to you stringing the spindle on the bow, putting the spindle on the pressure lever brace and inside the reloading base. Then we're going to fill the pressure lever brace with weights, and then we're going to give it a shot. Alright, here we go. Alright, so the first thing I have to do is string our spindle. So this gets a bit wieldy, but it happens the same way as the smaller version, where we start with placing the spindle to the cord and then wrapping upward toward what would be the tip of the bow. Okay. Work that down. Now, as we start to gain tension, the bow should go straight up and down. Okay. That way we can wrap the cord that way. That looks like that might be the right tension. So how does this spindle get on the base and brace? Well, the way this one works is the brace has to go in first and then shoot in the base end. So this will go up. Now don't put your weights on first, obviously. So this goes all the way up. The brace end goes in first. I lost one turn of my cord. And then the bottom goes in. Okay. Now, I've got to get as much of the cord even as I can. Okay. I'm going to brace against the fire dojo. As you can see, the bar holds the other end of the bow. So, and that's how that'll work. Start loading up some weights. So the large ones go in first. Here's a 6.5 kilos. Careful. Another 6.5. Or 14.5 pounds. So that's almost 30 pounds. Here we have another, let's see, 9 and 9, 18. Another almost 20 pounds. And a little 4.4 pound weight. I might need some more, but we'll at least get it warmed up. All right, and we're ready to get it warmed up. Okay. See the smoke coming from the bottom. All right. I'm going to fill that notch a little higher. And back we go. All right. Now we're going to try again. All right, so we're getting ready to go. And now I mentioned before that there needs to be a pillar structure for the pressure lever brace to actually work. Well, even though it's on these two wood studs connected to this frame. The frame, like a base with a bow drill, has a hard time staying stable with the unilateral force. Okay, so I have this unilateral force going back and forth, and the whole frame of the Hidojo goes back and forth too. So it's not a very stable frame in that sense. It's really a table for me to work on. So what you have to do is stabilize the base. You have to pin the base down like you saw me do with the bow drill or the Egyptian drill. So what I've done here is I've basically put some beams to support. You can see them on the angle there on each side to stop the unilateral force of the frame moving for the giant drill. Okay. And another thing too is we need to add more weight. I have these cement bricks than what we have up here. These concrete weights. And at the end, I'm going to weigh all this on a scale and tell you exactly how much weight it took to make this work. Now we have the sodal down here, okay, and we're going to fill the notch completely with the coal extender, because that's really going to reduce energy. I'm definitely not going to try to fill this notch. This notch is really big. Now you think because everything is to scale and to size, it would take just as long to fill the notch as a small notch, but that's not true. The coal dust that comes out really just comes out as fast as a normal bow drill and base. So you really want to fill this notch, and that's a very key point. You want to fill this notch all the way to the top. All right. Now this sodal reload that I have in here, I chose for two reasons. One, it was pretty convenient because I had a large cylindrical section that was ready to fit in there. Okay. The other thing too is I definitely want something of a low density because this is such a large surface area. If you're going to have a large surface area, it needs to be offset with a lower density, with a less hard wood, and therefore we're going to use the sodal. Now if I had a harder wood in there, I would definitely hollow it out, okay, to reduce that surface area and keep the friction on the outer ring of the reload in this case. Okay, so we have it bound around in our moderated method. The bow is going to rest on the bow bar, and you're going to see me just do the method. All right, and here we go. All right, so just to kind of show that this is not a cut and paste kind of affair, here I have a lamp faced over the notch so that you could see that I'm filling the notch with some sawdust and some coal extender. Okay, get that in here. Just so you can see there's, well, not a coal in there already. Alright, and we're going to back up. And so this is not a cut and paste kind of thing. Let's adjust the camera. Right to where I want it to be. Say hi, Jake.
Hi.
Alright, so we're going to remove the light so that you can can see into the notch. Okay. Good, Jake. Just don't move the camera. And there's our bow. It's sitting on our bow bar. All right. Now we've secured the heat dojo down because of the unilateral force, and it's a pretty extreme force pushing this back and forth. So I'm going to start off slow, get it warmed up, and try to go to town. I've put the concrete blocks up top, and then we'll get a weight after that. All right. So let's give it our shot. There. Let's see how we're going to tighten that up. I put all that weight on there and it's still slipping. Alright, so I made a few changes. I had to take some of the weight off to take the spindle out, which I'll tell you is a real pain, but you have to take the time to do it. I mean, you're all by yourself. So I'm going to put one more brick in instead of two. And I lowered the bow bar because I think the fact that it was high made the cord right up the spindle all the way up to the brace end. So I lowered it about half a foot. And again, so you see, I have the lamp over the notch area. So you can see there's no coal in there right now. It's not smoking. There's nothing in there. I don't want you to think this is a cut and paste thing. Alright, let's put that back on the stand. Put this around. Get it lined up again. I'm sorry I can't get the whole thing into frame. Let me get this warmed up, see how we do. Starting to smoke. Now the important thing is you really have to use your legs. Hold on. Unfortunately, it's cooling down while I have to fix this. Forgot to put the other weight on. Oh. Keeps riding up. Oh, finally. All right, here we go. Let's get our light. No cut and paste job here. Hold on. And there we go. All right, I'll be back in a second. Hold on. All right, I'm back. Sorry, I needed a minute to, first of all, catch my breath and take the weight out of the pressure lever brace. Okay, I have the lamp back, and here's our reloading base. Okay, take out one slot, take out another, and here's our reloading base. Let's pop that coal out, shall we? What do I got? A little sliver of wood. This will be the biggest coal you ever see. And here's our reloading base. So when this gets old, I just need to fit one to another size to fit in this slot. That's a huge coal, right? Just for comparison, how big that is. All right. All right, so this is science of the basic form. So we're going from right to left, structure to function. And here we're understanding our pieces. So we try to make things to scale. Okay, our bow, our spindle, our reload, our pressure brace, whatever form that takes. Okay, our stability, all 22 variables. And you go down the list, right? Need, skill, reason, means and resources. So what was my need? My need was, it was very important that I prove to you that balancing the 22 principles, you can really make this work. All right. So we're doing this as a one-person operation, and we assess our pieces. Okay. This is a drill axis method that we diagnose. Okay. There's a bow involved. In our assessment diagnosis, we're using my moderated bow Egyptian cording method. We have a reloading base for the basic means and resources of being able to supply a new base each and every time without having to make a huge one such as this one, which is really unnecessary, especially when I'm doing demonstrations. And for teaching and explaining the 22 principles, explaining and demonstrating the balancing of the 22 principles. So I've planned everything out, implemented, had some problems. We had some complications, which you saw through our evaluation, made some adjustments, we'll plan again, implement it again. And our final evaluation is this. A success. After running into a few complications, right? Stability of the Hidojo here, structure. Again, you're going to get your basics down for the toggle drill before you attempt something like this, which I've mentioned a few times. Okay. Our reload is a low density, although high surface area of sodal. Our bow is rattan. Our cord is actually a clothesline, regular cotton clothesline, which is 1.5 times the length of the bow for the moderated method. Okay, and everything held together, luckily. Now, so what I'm going to do right now is weigh all these weights and tell you what the actual weight was that we were using, so you can calculate that too if you need to. All right, be right back. All right, so we're at the end part of the science of the basic form for the giant drill, and this is the weight that I used. So the cement weights that you see there, that came to 40 pounds. And this cement brick came to 25 pounds. So that's 65 pounds plus the weight of the pressure lever brace. Okay? Which is probably, I'm going to guess, maybe 20 pounds, all right, of weight in itself. So we're looking at least, at least 85 pounds that was sitting on top of that spindle. All right. So what we're going to do is we're going to move on to the art of the variation part segment and keep on going. All right, let's go. All right, and welcome back to the giant drill. And this is going to be the art of the variation segment of this part of the bow drill. Now, here's what I've done. I've taken the pressure lever brace. This is the reloading base down here. I took the pressure lever brace and I turned it backwards. Okay, I made it opposite. And here it's over my table. Okay. And what I'm going to do is I'm going to make a torque spindle. So here I have a section of Atlantic white cedar fence post, and I'm going to make a torque spindle out of it. It is 5 inches in diameter, and I'm going to make a reloading hole socket there on the base end. As you can see, the brace end has been kind of carved out. I'm going to make sure that's fitted well and is balanced to fit in the brace hole socket of our pressure lever brace. Okay. And this is going to sit right on the table. So I'm going to secure this reloading base here on the table, and the pressure lever brace will hold the spindle on top of the reloading base. And here's our reloads. Now here's our other spindle that we used before, and this is a 2.5 inch piece of sodal. Here's the sodal that came from. This section, it's 2.5 inches across in diameter. There's one that's 2 inches for comparison. Okay. And as you can see, this one is held in here with buckskin. Now, I'm going to use the drill with this 2.5 inch hole cutting bit to make the same kind of hole down here on our torque spindle. Now, this is 5 inches and this is 2.5. That means that the torque spindle is twice the diameter of what the reload is going to be. So we're going to get a lot of torque. Okay, I'm going to leave the pressure bar there for the bow when we're ready, and we'll make our modifications as we go. Alright, so I'm going to make this hole, fit the reload, make sure that the spindle is set up on the pressure lever brace and the reloading base is secure. And we're going to give it a go. Alright, be back. Alright, by the way, here's how I cut this hole out. I start with the 2.5. Alright, now when I start to go in, that leaves me with the problem of trying to get this out of there. So what I do is I just keep going down in size. So here I do the 2-inch, the 1.5, 1 3/4 inch, and I just keep making my way down to eat out the inside of that circle. Now I'm just going to chisel all that out because I only went down halfway, and then I'm just going to go again, and I'll show you the result. All right. So here I took a sturdy screwdriver and I just popped out all of those inner sliver pieces, and I'm going to keep drilling in now. Don't drill all the way down and then try to get these things out. Just do a little bit, pop everything out, drill down a little bit more, pop everything out. Okay, take your time with this, or you're just going to make more work for yourself. I know, because I've had to do this before. All right? All right, let's keep going. All right, so we got our hole carved out. Okay. And it's 2.5 inches, probably a little wider than that. And I took the leather buckskin pieces that were holding the other reload in. I took that out so that I can wedge in the new reload. The new reload I made. And we're going to put that in there with the camera. Hold that with my leg. And drive. Reload in there. There's our new reload in our new torque spindle. Looks like a rocket ready to take off. Alright, so I'm going to get this fitted and set up for the pressure lever brace and the reloading base. Alright, here we go. Okay, so I've cleaned off my table a little bit because I'm getting all mad scientist. I'm really scared to show you the rest of the room, but so here's our pressure lever brace here on the inside of Fire Dojo, and here the spindle sits on the reloading base. Okay, I had to carve out the brace end a little bit to make sure that it fits inside the socket. It was a little wide, so it had sidewall friction, and we don't want that. So I'm going to wrap the rattan bow around the spindle and secure the base. So how this works is I have to slide the reloading base with the spindle in so that it's at the correct height. Okay. So I'm going to cord the spindle and then push the spindle with the base into position because it's a really tight fit. Then I'm going to secure the base and we're going to start bowing and see how we do. I'm going to fill the notch, obviously. Here the notch is really completely empty, but I'm going to throw some sawdust in there, fill that, the height of that, fill the space of that, so I don't have to bow for like half an hour to get this thing to fill. Now, as you saw with the last one, the energy principle variable is a big deal. So with the torque spindle, we're going to see if that's a little easier to turn because we have more turning force with the spindle. Okay? Onward and upward. Here we go. All right, so we've corded the spindle, and I've done the bow bar before, but here's what I'm doing. I'm doing something new. I'm doing a double bow bar, and that's to actually keep the bow in one place. We saw the cord riding up earlier, and I don't want that to happen again. So let's see if this double bow bar keeps the bow in place and keeps the cord from riding all over the place. Now you can see here the notch is empty. Here I have a handful of sawdust, which we're going to throw in there, because what we really need to do is fill the space. All right. Now I've taken those two pine boards that you saw that were holding the reloading base in place down here in the front. Okay, and I've put some holes in them. I nailed them down, and it's holding the reload in place, the reload base. Jake, just hold that for me 1 second. Thank you. Now what I'm going to do is just put 2 more nails in on the sides of the, if I can find my hammer. So you can see what I'm doing. Now the reloading base shouldn't really move side to side, but rather fix it now than later. In place. Don't mind the mess. Okay. So Jake is going to stand all the way over here, and he's going to watch me start to bow. Okay. You got the whole thing in frame? Maybe you should back up a little bit. Okay. You're leaving? All right, cut. All right, sorry about that. My son had to go somewhere. So here we are again. The notch, you can see, is filled with dust, but there is no coal. It's not smoking. Okay. I put the weight in our pressure lever brace. We have that concrete brick. We have those concrete filled weights. Again, that's probably close to 80 pounds. Total, including the pressure lever brace. All right, so this is not a cut and paste job. You see that this is no trick. So I'm going to put this on the camera stand. Get everything in focus. Let's see. Got our double bow brace. They're going, okay. There we go. All right. I think I'm going to lighten it up. Alright, so we're back again. And what I did was I had to record the spindle. So what I did was I shortened up the line a little bit to make it a little tighter. I made another knot in it and pulled the string up, and that seemed to make the cord a bit of a better fit. The other thing I did was I took out some weight. So I took out the cement block and 2 weights and lessened the weight a little bit, because I think with the torque spindle we're going to get a lot of turning power. So again, I took everything out of the notch so you can see that it's empty. And I'm gonna fill it again. With the sawdust, just to fill that space. Okay. Let's see if we can't get us a coal. Now again, we're not cutting and pasting, so we're going to put this on the stand. Let's see. Let me back this up. I want you to see everything. Just bear with me here. All right. As good as it's going to get, I guess. Starting to smoke. So I'm going to make it up with some speed. Oh, very nice. All right, no cut and paste here. There we go. Let's get that light. Beautiful. All right, ladies and gentlemen, now I have to admit, that was a little easier. Now we needed less weight. I'll get you the weight for what that was. And so here's the giant drill on a tabletop. So the tabletop version of what we just did, and it's a torque spindle for a lot of turning power. All right, on to epimethii. Okay. All right, so this is the epimethii section of the giant drill. So we just got done doing art of the variation. So we did a tabletop version, torque spindle of the giant drill just now. Got a coal and played around with controlling the space of the bow to keep the cord from going up and down. So we did a double bow bar, which I think was a big help because we only had this short space for the spindle. So if it started riding up and down, that's actually pretty serious. Now, what you don't really see is me changing the weights in and out of the top of the lever brace. That could be a real pain. So if something is wrong, you gotta take the weights out, fix whatever it is you gotta do, put the weights back in, well, set it up again, put the weights back in. If something else is complicated, you gotta do that all over again. So, there's a lot of satisfaction in finally getting it to work. So, art of the variation, you know, we're going from left to right. So we know how it works, and then we're just playing around with the structure of it, of the physicality of it, and seeing what you could pull off. So we did that with less weight. The weights were half. So half of 80 is 40. So we only put 40 pounds up top that time. And it was a little less effort than before. And got it to work. So 2.5 inches of surface area of solder for the reload. That's a lot of surface area. So, and the torque made it a lot easier with the turning force. So that was a big deal. So we're going to move on to our next section, the pump drill. And that's going to be very interesting because we're going to leave the bipolar type technique and go to a unipolar. Also, we're going back to a bilateral force instead of a unilateral force with a bow, which you'll see. And it'll be a lot of fun. A lot of reloads, a lot of strange flywheels, which you see, which is another device. So we're going to get on that. And let's keep going. All right? There's a lot more. A lot more to this than even up to this point. And always remember, try not to do the giant drill till you've mastered toggle drill. And the toggle drill section will be after following the pump drill. Okay? All right, let's go.